Alright, so the problem is asking us to find the tension in the rope. This is the crow sitting on the rope, which is a contact force, and the tension is the same on both sides because the rope is all one. So in knowing that, we know that the sum of the forces equals 0, which would be the F vector net equals 0 vector. So we'll draw a free body diagram showing the weight of the crow going downward, the tension being equal on both sides, we'll label that T, and the vertical, which we'll label TY. We're only focused on the vertical because there's no horizontal movement. We know that this is a right angle and this is a right angle, and we need to find theta to give us the tension of the rope. So in knowing that, we use sine of theta, which is the opposite over the hypotenuse, which would be sine of theta equals ty over t. So we'll multiply both sides by t to give us t sine theta equals ty. And knowing this, we'll go back to the sum of the forces equals 0, and using ty plus w equals 0. And in this case, w will be a negative because the weight's going downward. So it'll be ty plus ty minus w equals 0. We'll combine the ty's to give us 2ty, and we'll move the w over to give us a positive w. Then we'll divide both sides by 2 to leave us with ty equals w over 2. We already know the ty, so we'll plug it in, which is t sine of theta. So t sine of theta equals w over 2. And we're looking for the tension, so we need to get the t, which is the tension by itself. So we'll divide both sides by sine of theta, which will leave us with t equals w over 2 sine of theta. This would be our tension, and if we knew the weight of the crow and this angle right here, then we could find the tension in newtons.